We're going to start off with a quick review of all the grade 10 trigonometry that you did, which is basically right triangle trigonometry, and in grade 11 we go to non-right triangle trigonometry. I'm not going to go through the really important stuff, which is just checkmarked right here. Really what we're just going to do is review how to find angles and sides in right triangles. So first of all, go ahead and do as I instruct and draw these two triangles and measure the angles. So I'll get you to pause, do that, and see what you see. Write down what you notice. Okay, and then, so in going ahead and drawing those triangles, what you should have noticed is that they have the same angles. Both triangles have the same angles. But they are not the same triangles. And you might say that one is bigger than the other, or one is smaller than the other. But the angles are the same. And the key idea in that little activity, and again, you might have done it in grade 10, but the key thing I want you to see from that activity are these three key points. The size of a triangle does not affect the angles. The size of a triangle does not affect the angles. What affects the angles is the ratio of the sides. And by ratio, I just mean comparison. So if you look at this triangle right here, see what I mean in a sec. So the ratio of the sides, the comparison of the sides affects the angles. And in this case, we can say one leg is 1.5 times bigger than the other. So in our picture right here, it doesn't matter which one. This one right here is 9 units. This one right here is 6. So 9 is 1.5 times bigger than 6, just like 15 is 1.5 times bigger than 10. So this becomes really important because really when we're doing trigonometry, it is a relationship between sides and angles. And as it says, no matter what kind of triangle you're looking at, there is a basic relationship between sides and angles. So in this picture right here to the right, we're still looking at a right triangle, but it really doesn't matter. And I just want to use this little picture to highlight what I'm going to try to be consistent with. If I draw a right triangle, the hypotenuse is always going to be C. Notice that the angles are uppercase and the sides are lowercase. And what I want you to notice is the letters correspond oppositely. So notice that little c is opposite angle C, and side little a is opposite side big A, and so on. And it doesn't matter if you have a right triangle or a non-right triangle, this relationship between sides and angles always holds. And this is a common sense thing, this is a physical thing, but this is always how you should check your answer. So here's the basic relationship that always holds. Sides opposite larger angles are longer than longer than, sides, opposite, smaller angles. And that is a simple physical idea. And with a right triangle, the hypotenuse is always the longest side, and you know that from elementary school, is always the largest side. As the right angle in that right triangle is the largest angle. So this basic relationship is really important moving forward, grade 11, grade 12. So here's those basic trig ratios that you learned in grade 10, and this word might make sense here, SOHCAHTOA. Oops. SOHCAHTOA. Like a wine volcano. Now, the thing that is really important in SOHCAHTOA, the relationship, is identifying opposite and adjacent. And those are relative terms, meaning opposite depends what angle you're talking about, and adjacent depends on what angle you're talking about. So I'm going to color code my angles. Here's my angle A. I'll color code angle B, and I'll color code angle C. Now, the hypotenuse is always the hypotenuse. That never changes. But relative to angle A, here's our little a, and relative to angle B, here's our little b. But relative to angle A, little a is opposite. And opposite really just means across from. So side A is opposite angle A. Now, relative to angle B, relative to this angle at the top, and side A is adjacent to. And a good name for adjacent to might be touching. Usually I find determining the opposite's the easiest one. So this is what I mean about relative. Side A changes with our vocabulary depending on what angle you're looking at. When we look at little b, side little b, relative to angle A, this one is adjacent to angle A. But relative to angle B, this side is opposite angle B. So this is the most important thing in using your grade 10 trigonometry, is if we can understand what is opposite, what is adjacent, and the hypotenuse is always the hypotenuse, then we're simply going to plug the numbers into the right formula. And that's what these things really are. Like, these things are just really formula. You don't have to think about them. There is a relationship. We just have to know which relationship to use. So a little bit back to the grade 10 then, before we actually go and solve some. What do these ratios mean? So for example, if we have a sine ratio at 30 degrees is 0.5, which it is, we would mathematically write it as that. The sine of 30 degrees is 0.5. Now, again, that might be a number your calculator gives you, but here's what is really important to understand. Given that the sine ratio is the ratio of opposite to hypotenuse, what that 0.5 really tells us is, says the side opposite to our 30-degree angle is 0.5 times bigger than the hypotenuse. So it has a meaning. It's just a comparison of the opposite to the hypotenuse, and that combination is called the sine ratio. So in this example, just to make sure we understand the physicality of these relationships, Go ahead, pause the video for a sec. I have to draw this freehand. So here's what mine might look like. And again, this isn't going to be perfect, but it's not going to be bad. So this might be 1 centimeter, and this might be 10 centimeters. And again, the ratio opposite to hypotenuse. And we would get a small angle right there. Okay, one last thing for this part of the video before we move on to actually solving. Again, is just really trying to understand what these mathematical words mean. So the cosine of 60 is really asking us to understand the relationship between the adjacent side to the 60-degree angle in a right triangle compared to how long the hypotenuse is. So if you punch this into your calculator, here's what your calculator is going to spit out. The cosine of 60 degrees is 0.5. And again, what this says is the side adjacent to, so that's the cosine ratio, adjacent to the 60 degrees is 0.5 times bigger, or as large as the hypotenuse. Now again, there's an infinite amount of triangles that we can draw, but they all have to have the side adjacent to is 0.5 times as big as the hypotenuse. The tangent of 50 degrees is 1.19. Remember, the tangent ratio in a 90-degree triangle is opposite compared to adjacent. So what that number represents is the side opposite to the 50-degree angle is 1.19 times larger than the side adjacent to that angle. The side adjacent to the 50 degrees. So I'm going to pause there, and we'll finish off the second part of the video in the second tutorial.